You're not going to want to miss this episode of the AI Show. We talk all about beyond the prototype, scaling multi-agent AI apps with Azure Cosmos DB. My friend James, make sure you tune in. Hello, welcome to this episode of the AI Show. We're talking all about beyond the prototype, scaling multi-agent AI apps with Azure Cosmos DB. How you doing, James?
Good, Seth. Really excited to be here with you today.
So tell us who you are and what you do.
Sure. So I'm a product manager in Azure Cosmos DB. I lead product for our query engine, as well as a lot of our AI investments, like different retrieval methods like vector search and full text search. So my head is always in the agentic application space and what developers are doing and what they need to build great apps.
And this is cool because, look, betwixt us friends and maybe the people watching, there's a lot of here's how you build an app, but they're all fake apps, shall I say, in the sense of this is kind of a cool toy app to understand. But building real production systems with this stuff has got to be difficult. How does Cosmos DB help?
Yeah, so I mean, as you know, Cosmos DB is this global scale cloud native database, right? That some of the world's largest customers run on, right? And so when you have a database that has those enterprise ready capabilities like high elasticity, auto scale, 5 nines of reliability, it really lays down this foundational data platform for you to build your applications. So as you go from POC to small scale to enormous planet scale applications, you can still use Cosmos DB in its core setup. It'll scale right along with you.
Yeah, and when we talk about planet scale, if you let's just say I built the coolest AI thing ever, it's more than just the demo, right? Because scaling this thing actually requires you to do things differently, and these things have to scale, right?
Yeah, absolutely, right. So you have to think about not just how much data you're going to have in the database, but what those transactions look like, what the volume of those transactions. So if I go from having vector search for RAG from just a couple queries per second to maybe 100 queries per second, 1,000 queries per second, I have 10 million vectors to a billion vectors scale, right? So you really need to sort of think through your partitioning and data modeling strategy for how you're going to be able to maintain high performance, high accuracy search and retrieval, really as your application evolves.
All right, so you brought some slides. What are we looking at here?
Yeah, so let's take a look at how some customers are actually building real life applications, agentic applications using Cosmos DB, right? So we have Toyota that has a multi-agent RAG pattern, right? So they have multiple different sub applications that are using multiple different Azure resources depending on what they need for that particular agent, right? So from having models that they need to index data from, say, SharePoint, where they use Cosmos DB and SharePoint and Azure AI Search, to applications where they need really robust reliability and performance, where they use Cosmos DB by itself and leverage our native vector indexing technology powered by Microsoft Disk-A and Vector Index. So it's really a great example of Toyota really using the right tool for the right use case to enable their own employees to find the right data that's sort of spread around the Toyota organization.
And this is interesting because I'm looking at this, and it's showing how Cosmos DB can be used in different ways to do retrieval augmented generation. Like, for example, I'm seeing there's embeddings with the vector database version of Cosmos DB, but you may be using, for big data, you may just be using it as a query something kind of thing, right?
Yeah, that's exactly right. So it's the same instance of Cosmos DB, and it can even be the same container or database. But you're storing chat or session history inside Cosmos DB, in which case there's different retrieval patterns. And maybe I want the last 10 items of our conversation that we talked about to bring the context to the large language model. But I also maybe just want to do RAG or vector search powered RAG over some set of documents or a set of operational data to really find the right thing at the right time for my LLM.
So this is really cool because I think what you said, if I'm hearing right, is that this may even be the same instance or same database, but used in different modalities with different documents and different databases.
That's absolutely right. So Cosmos DB is a schemaless database. So you can have data items or documents that adhere to one configuration for one use case, and then adhere to another schema, if you will, for another use case, and have that flexibility to have multiple scenarios supported even in one container.
And by the way, if you don't know, like, I don't know if you know this, but when I was James, when I did the demo at Microsoft Build, we actually use Cosmos DB to store some of our settings, some of our prompts, and so it's really flexible way of actually doing stuff. Now, is there a way? Can you show us something that you built? Because I know obviously we're not going to be able to look at Toyota's code, but is there something you can show us that can give us a sense for what this actually looks like in practice?
Yeah, absolutely. So let me fast forward a little bit here. I'm going to jump over to this workshop that actually we created for developers to go and try to use Cosmos DB to build multi-agent applications themselves. So we have this, what we call our multi-agent banking workshop. There is a track where you can use .NET and semantic kernel, or a track where you can use Python and LangChain and LangGraph. Essentially, you're building a multi-agent application. The scenario here is around a banking application, so you can have different agents perform different banking tasks. And then this leverages, Azure OpenAI, Azure App Service, leverages application insights, and importantly, Cosmos DB to manage, the statefulness of the agentic application, to manage the chat history of the application, and to also manage RAG. So it does vector search over some key banking offer information as well.
So let me take a step back and I'll put our faces on so people can see. So effectively, Cosmos DB is not only managing like the information store, or what is sometimes called long-term memory, but it's also storing the thread, the conversation, which is sometimes called short-term memory. Am I getting the nomenclature right? And is this accurate?
Yeah, I think so, right? So the short-term memory you can sort of think about as like the chat history, like what you chatted with the agent not too long ago. Long-term memory could be something that is much longer in the history, or it could be something that's even across sessions or across threads, right? But you can use Cosmos DB to store all sorts of memory and do all sorts of complex memory scenarios. We just show a couple of examples here in this workshop.
I see. But so to distinguish between long-term memory and short-term memory, there's also the notion of like just general knowledge that could also be in Cosmos DB, that all three of those can participate in this agentic kind of application.
That's absolutely right. So we have a specific container for, say, chat history. We have another container where we're capturing the state of the agentic application. And we have another one for knowledge. So this is like, what banking products does the banking agent want to try to sell me or try to offer to me if I'm trying to solve a problem?
Yeah, what a cool way to think about this. And by the way, if you're not thinking about your application this way, thanks so much, James, for showing us, telling us you have different kinds of memory that these agentic systems can access. And what you're showing us here is that, if you're having a hard time putting these in multiple places, you can actually use them all in Cosmos DB. Short-term memory for chat history, long-term memory for stored history and chats. But then you can also like store vector-based embeddings to pull up larger documents to do standard knowledge retrieval. Yeah.
Exactly.
Okay.
So let me show you an example here of actually what this looks like. So we have this application, right? So here's a really a quick example of like what like chat history would look like in Cosmos DB, right? So you can see that in our application, it's a multi-tenant application. So we've designed it so you can have multiple tenants or multiple banks in this application. We have multiple user IDs, so we can separate out the threads or sessions by individual users. And then we can see like text that was said by this user, right? So what's the balance of this certain banking account? And then any other metadata we want to capture about the experience. And so we go through this, we see every turn, everything the customer said and everything that the LLM said is captured here for chat history. So we can use it to ground our model again later, right?
I see. And you would use the session ID to get the array of things and then sort it by date. And then you can do it like this is great. This is an example of short-term memory that can be pushed to long-term memory to be like, hey, I called you the other day, and you could totally bring this up and be like, oh, I totally know what you're talking about. This is really cool.
Exactly. And you notice that here we're maintaining session and tenant ID as part of the document itself. But if I want complete isolation of my tenants, I can do that also, right? I can set up a different container for different tenants, or I could keep them all in here and set up my partition key in such a way where it's keeping them separate. But we can see that in this application, we have multiple different containers with different items. So we actually have checkpoints here. So if you're familiar with LangGraph, there's this notion of checkpoints. So you can capture the state of your agentic application, right? So you may want to capture the state if your application suddenly crashes, right, or suddenly dies or has a disconnect. You want to be able to bring up the agents in the same state that they were when you last had them. And we have an integration with LangGraph that does just that. It captures the statefulness and brings it to Cosmos for storage.
This is great. Like, and like I said, here, let me put my face up. One of the things that was cool for me when I was debugging the application is that I was able to run a local version of a Cosmos DB as in dev mode. Are all the best bells and whistles in there? Can I do vectors in that one too?
Yeah, so there's usually a little bit of lead time between when we have advanced features available in Cosmos DB to try and when we have it available. And I think the emulator is what you're talking about.
Yes,
right?
yeah, that's the word. That's the word.
Yeah. But we do have a free tier of Cosmos DB. So every subscription is entitled to one free tier, and you get all the bells and whistles with that free tier. And then, of course, we have our serverless option, which is incredibly cost effective and actually really good for those POC applications.
Yeah, that's what I was going to ask, because like in general, like the notion of a free tier is awesome, because kicking the tires. If I got to kick tires and I don't like the tires, I don't want to pay for them, right? Kind of thing. And I love that the ability to do that. And like I said, I've used Cosmos DB to store all kinds of cool stuff, like from settings to an app, chat conversation history, and now you can actually vectorize a lot of this stuff to do so. So let's take a look at some of the code to see how this is implemented.
Right. So we basically have so this is the Python implementation. So we have a fast API server running. We're using LangGraph to compile our agentic application. And this is just a really simple way of surfacing this through a fast API application, right? Now we have examples for each of our agents, right? So this is our transactions agent. So if we want to do banking transactions, right, we can define our tools here as simple functions, and LangChain and LangGraph make it really easy to surface those as tools for our agents to use, right? And so in this workshop, you can actually see some best practices for how to structure your tools, how to write prompts using a prompty package in Python for your specific agents to ground them and make sure that they're doing the right thing in the right way. And then we even have tools for things like how to execute different searches in Cosmos DB, like the vector search that we talked about, or how to retrieve the chat history. So there's a lot of really good best practices that are in here as well. And of course, since we're just doing a POC, when you deploy this, and by the way, you can easily do AZD up and deploy all the resources into Azure and have it all set up for you.
Nice.
It uses Cosmos DB serverless, so we really focused on making it really inexpensive and really easy for you to get started and walk through all the steps to developing this application. And once you have deployed it, you get this nice little interface here. So you can choose a multi-agent baking application. You can choose your user, and you can choose your tenant, right? So we talked about this in the multi-tenant fashion. And here I can see my other chat sessions that are here retrieved from Cosmos DB, right? So if I click on this one, I can see the previous conversation that I had. This is not stored in memory. This is all stored in Cosmos, like resurfaced here for me. Or I can go back and start a new chat conversation here, and I can say something like, "Tell me about my bank accounts." And this is powered using, I believe we're using GPT 4.0 here. So this is telling me, okay, it's hitting first my coordinator agent, so it's going to ask me about what I want to do, and it's identifying that I want to ask about my bank account. So it's going to transfer me to a different agent, so I can ask about balance inquiries, right? And so now I can say, how much is in account ACC3? We'll let that run, and it'll come back to me and give me the right answer here, right? So it did a lookup for my account in Cosmos DB and got the number, so $200, and it's surfacing it to me, right?
And here's the thing, like, if you're looking at this, I can see, like, it feels like it made a mistake. I don't know if it did or didn't, because the coordinator went twice. But the cool thing about this is because this thread is stored in Cosmos DB, there's like a replayability of being able to see what happened, how did it execute, and then maybe even what went wrong during conversations. And so this chat data is gold for for tuning, fine tuning models, for seeing what went wrong, and all that other stuff. This is great.
That's exactly right. Yeah, I think the core agent coordinator here is more of a UI thing potentially, because it was able to answer the question effectively, and that balance tool is only available to the transactions agent. So, but we can go and do a little debugging. But you're absolutely right, right? Like storing that chat history and session data, you can do all sorts of great stuff to improve your models, improve your applications. And for something like a banking application, you probably want to record it anyway for auditing purposes, right? So really great use cases there.
Yeah, and I've been to, like, in London, I've been to the tall buildings with the bank folks, and the reality is that with regulated industries such as healthcare and these, it's important to be able to write this stuff down and know what actually happened, see what decision processes happened. This is absolutely great. So let me where can people go to learn more about this stuff?
Yeah, so we have a couple links that we can share. I think we have an AKMS link here where you can go and check out some of the new search capabilities that we launched at Build this year. So we GA'd our full text search capabilities. We have numerous integrations, including with Azure AI Foundry agent service for thread storage. And we have a lot of cool stuff with like link compatibility for vector search and for full text search if you write your applications.net. A lot of really new and nice advanced features. One of the things we also launched was this notion which we're calling sharded disk ANN, right? So disk ANN is a vector indexing technology that allows Cosmos DB to be super scalable and super cost effective with vector search. Well, now we're doing it in a way where you can actually build multi-tenant apps and have those applications, have those tenants have their own individual vector indices by sharding them on a tenant ID. So essentially you can have very scoped and focused vector search that's very cost effective in your multi-tenant applications, just in one Cosmos DB container.
That's impressive. And then obviously, like, this demo you showed isn't just like a demo, but it's also something that you can go and build today using this GitHub AKA link. Is that right?
Yeah, absolutely. So you can go check out the workshop, and like I mentioned, there's a .NET and a semantic kernel path, and then there's a LangChain, LangGraph, and Python path.
Well, dude, we need to have you on more often. I love the practicality of this stuff, because sometimes all of this stuff feels a little black box-y, and I love the ability to use a single source of knowledge that can do multiple different things. And then the other thing is, if you're using Azure AI Foundry, all of this stuff can be integrated together, correct?
Yeah, absolutely. So like I said, we already have a first class integration that went GA at Build for thread storage in Cosmos DB. So you can give it a try there.
Amazing. Well, James, thank you so much for spending some time with us, my friend.
Cool. Thanks a lot, Seth. It was a blast.
And thank you so much for watching and learning beyond the prototype. And this is the key: scaling multi-agent AI apps with Azure Cosmos DB as the backend. Thank you so much for watching, and hopefully we'll see you next time. Take care.